Population growth. In ecology, population growth means the change in the number of individuals in a population with time. Change in population is determined by 4 factors: birth, death, emigration, and immigration. Population growth can be exponential growth or logistic growth. A population shows exponential growth when abundant resources are available and the members of the population are free to reproduce at their physiological capacity. This form of growth can be represented by a simple equation, that is d dt of n equal to Rn, where d dt of n is the change in population size per unit time, n is the population size at time t, and R is the intrinsic rate of natural increase, also called biotic potential, which is the inherent property of an organism to reproduce, that is, to increase in number. Here the rate of increase in population is geometric, not arithmetic. That is, the population is multiplied by a constant fraction, not a constant amount. When the population size, that is n, is plotted over time, t, as we can see in the diagram, a J-shaped growth curve is formed. Example of a population exhibiting exponential growth can be seen in a population that is introduced into a new or unfilled environment. But in real situation, it hardly occurs because as population density increases in an area, each individual has access to fewer resources. So a particular environment can only support a maximum population size. The number of individuals of a particular species that a particular environment can support indefinitely is called carrying capacity, which is represented by the letter K. Carrying capacity is not fixed. It varies over space and time. It is determined by various factors like predation, competition, climatic conditions. So the growth of a population eventually slows as the population reaches the carrying capacity for environment. This results in an S-shaped curve, also called sigmoid curve, of population growth, known as logistic growth. Equation for logistic growth is different from that of exponential growth. If K is the carrying capacity, then K minus N is the number of additional individuals that the environment can accommodate, and K minus N divided by K is the fraction of K that is still available for population growth. So equation for logistic growth can be modified by multiplying the exponential rate of increase, that is Rn, by K minus N divided by K. The term K minus N divided by K indicates how much of the resources are still available to populations. In the logistic model, the greatest population growth rate is achieved at half the carrying capacity, that is K by 2. Populations with a greater value of R will reach K more rapidly than the populations with lesser values of R. Now, as we can see the S-shaped curve, the population increases slowly in the beginning and this is known as acceleration phase. Then it increases more rapidly, called logarithmic phase, and eventually it slows down as environmental resistance increases, and this is known as the negative acceleration phase until equilibrium is reached and maintained.